So I've been getting a lot of advertisements for some interesting stuff. Um, Everybody thinks they can sell me products, and but usually that's not the case. And this is one of those times where I got serious issues with a certain product. And today we are looking at the EcoFlow Wave portable air conditioner. So here's the product. It is a battery powered, has a rechargeable battery built into it. Air conditioning unit. It's portable. It is $1,200 to buy that. I don't know if it's available at the moment, but this company is offering it for sale. All I can say is the idea is nice, but the execution and the marketing are a bit problematic. And the whole idea of air conditioning is removing heat from a space, a room, a house, a building, a car, whatever it is. If it's air conditioned, there's a machinery that removes heat from that enclosed area using principles of refrigeration, which I don't need to explain how that works. You can go online, but basically the whole idea is you are using external energy in the form of electricity normally, or if it's your car, it's belted off of the crankshaft of your engine to drive a compressor that pumps the heat up in temperature so that it can be rejected to the outside, it can be rejected to the ambient environment. So if it's 70 degrees in your house, Fahrenheit, and the outside is 90 degrees, the compressor is what enables that heat to be increased in temperature. The thermal energy that's in the room to be sucked out of the room, drawn into the unit, and then its temperature increased, and then it can be dumped into the outside. It's kind of like pumping water from a lower reservoir to an upper reservoir. You need work to do that. It could be a pump, it could be carrying buckets up a hill, it could be any of that. But in order to get the substance, the heat or the water, the energy or the water or the mass, to a higher energy environment, you need to force it, and that's air conditioning. So this air conditioner here is the same exact principle. It's a vapor compression refrigerator. So it's got inside of it, it has an evaporator coil, it has a compressor, it has a condenser, and it has a fan, or at least one fan, or at least one motor with two fans on it. And it's got an expansion device to allow the pressure drop from the condensation side to the evaporator side so that it can collect heat from the room. But when you collect heat from a room, where do you put it? Where does it go? So you walk down the street and you look at people's houses and they got these ugly, butt ugly window air conditioning units hanging out the windows. Like, has anybody ever thought, why in the world does it have to go in the window? Why does it have to go in the window? Well, the reason is because the window is a hole in the wall. It's the most convenient place to get rid of the heat. So you put the air conditioner in the window so that part of it's in the room and part of it's outside, so that you can cool the air that's in the room and you can heat the air that's outside, because you're sucking heat from the room and you're pumping it to the outdoors. That's why they have to be in a window. That's why central air conditioning or split air conditioning has the big gray box outside the house with piping that comes in to the, what happened there? With piping that comes into the indoors so that the heat can be moved by moving refrigerant gas. Now you can buy portable air conditioner. When I say portable, I'm not talking battery operated. I'm talking you plug it into a wall outlet that has large ducts on it. So what do they look like? Some people probably seen them, but portable air conditioner has ductwork. So here's somebody selling one, and let's try to make this bigger. Enough of that. Of course, it makes the text bigger and not the picture. But what they do is they give you ductwork that allows you to blow the heat, the hot air, from the condenser side of the air conditioner to the outdoors. Alright, so they give you all these fittings. Web design is absolute garbage nowadays. That's just a statement, an unrelated statement. Things are way too complicated, way too over-designed, way too bloated. I mean, this thing is chewing up the whole computer just to show a website. Alright, so we got air conditioner with all these hoses and all this stuff to get the heat outside. But this unit here does not have any of that shown. Alright? So my question is, where does the heat go? And I can tell by looking at this thing, by looking at the 5 photographs they provide, is that the cold air blows out here, the room air blows in, sucks in here, it gets cooled by the evaporator coil, the compressor lives in the middle someplace, and then air from the same exact room that you are sitting in is sucked into the back, goes over the condenser coil, gets heated up by the combination of the heat that you sucked out in the front and the electricity that it's using from its internal battery or from the outlet or whatever. And then that hot air gets blown right back into the exact same room that you're sitting in. In addition, this thing advertises that it evaporates the moisture from dehumidifying the air. So when you do air conditioning, you got to remove heat in terms of temperature. You got to remove humidity in terms of water that's in the air. So there's 2 types of heat. There's sensible heat and latent heat. Sensible heat is the temperature, latent heat is the humidity. This is a freaking video file that is maxing out my CPU on this computer. I love this web design. No wonder we need new phones every year, right? Anyways, the heat from the room in terms of humidity and temperature then is combined with the heat that's generated by the compressor in compressing the refrigerant. So the electricity that compressor is using, all of it, all 300 watts of it, or however much it is, has to go someplace, right? It's the first law of thermodynamics. Energy is neither created nor destroyed. Energy has to go somewhere. The second law of thermodynamics says that electrical energy is high quality energy. It's going to get downgraded to low quality heat, and that heat is going to be blown out the back in addition to the heat you're getting rid of from the front of the unit. Okay, you can kind of see where the problem is here. If you sat this down in the middle of a room, it is actually going to heat the room up. It's not going to cool it. Okay, yeah, you might get a little blast of cool air coming out the front, but the room temperature is going to increase, even though one side of it's blowing cold air, one side of it's blowing hot air. There's more thermal energy because of the power being used by the air conditioner. The marketing of this whole entire product gives absolutely zero description of that problem. So all I can say is the marketing departments haven't been talking to the people the engineers that designed this thing, probably because they just went to a contract manufacturer and a contract manufacturer made the product. I don't know the story, but for $1,200, I expect a machine that I can sit in the middle of this room just as if it were a space heater, that I can just sit here and it's going to cool the room down. No, that's not how it works. You need to get the heat outside. You need to remove the heat from the room. You can't just blow it back into the room you're trying to cool. Right? It is not going to function. It is going to crash and burn spectacularly, and you will be out $1,200. The only way to salvage this would be to build some kind of a frame so that you could stuff it in a window and have the back end stick out the window and the front end stick into the room, or cut a hole in your wall and shove it in the wall, or hook some kind of duct work to the back of this so that the air can be brought in from the outside and the hot air blown back out through another duct. That's the only way this is going to work. So that is definitely an issue with this. I just cannot wrap my head around how you can have a website with all this marketing literature, all these frequently asked questions, and they do not mention the problem of where does the heat go. Like, seriously, somebody is missing that. And that's the most important part of air conditioning, is where are you putting the heat? Because if you're putting it back into the space you're trying to cool, it's like digging dirt holes and filling them right back in. It is a completely futile activity. And you're wasting electricity, and you're wasting the money that you're spending on the machine if that's what you're doing. So that's it. All right, it's using 134A refrigerant. It's got a maximum cooling capacity of 1,200 watts, but then the max cooling power is 600 watts. So that must be what's used by the compressor. Oh, it evaporates the humidity back into the room and blows it back out the back. That's effective, right? It's got an inboard battery of. Oh, it's got an add-on battery. It moves 290 cubic meters per hour of air. Yeah. I'm nowhere does it say where the heat goes. Anyways, that's all we got for that. I'll stick with a window unit till we get that bug worked out.